What's up? I'm doing my presentation on integrals because I think integrals are really cool in what you can do with them, especially. So, what are integrals? In calculus, an integral is a mathematical object that can be interpreted as an area or generalization of area, according to Wolfram Math World. But there's a little example of it right underneath. So that I put a little overview of it. So the discovery of integrals was it was discovered by Gottfried Wilhelm um, Leib, Leibniz. I think that's how you pronounce it, but he was a German mathematician. He performed the first integral, um, the first integral math to find the area under the curve of y equals f of x, which is the graph of that. But, you get the point. On November 11th, 1675. So, very important. That's kind of like how I view it is the big bang of integrals. So, and here's some history on it that I thought was very interesting. So the ancient Greeks developed a system for solving areas and volumes called the method of exhaustion, which was invented by uh I misspelled his name. Eh, it's supposed to be no, I guess he's Exodus now, but it's supposed to be a U in between the E and the X. So I guess it auto corrected on me, but it's supposed to be uh yeah, I think you pronounced it Yox. You I'm gonna call him Exodus, but Exodus of Nidus in 370 BC, and then Archimedes or Arch. Oh my word, I'm fudging the names. Archimedes and in the third century BC innovated this system and used it to find the areas of circles and parabolas, which is very cool. But also, the ancient Chinese used a similar method invented by Liu Hui, I guess, to find the area of a circle in 3rd century AD, which that's pretty cool. That's like 6,000 years apart from each other. But I thought that was pretty interesting. But then, of course, in the 5th century AD, they later on uh, improve upon the system. It was actually a father and son mathematicians, two of them. They found the volume of a sphere. So that was something pretty cool to note about the history of it. And also, Leibniz used the long S summa to notate for integrals, but Isaac Newton would just use straight lines to indicate that he was integrating, which was pretty interesting that eventually everybody just started using Leibniz's, um, yeah, Leibniz's version of it. So, but then Joseph Fourier, a French mathematician, was the first to use the definite integral notations. Why are integration, why is it important? Integration allows a system for finding the area under a curve, and it is used in physics. It is used a lot in physics from what I have dealt with so far in Physics 1. I can definitely attest to that. And it just makes finding the area of complicated shapes much easier to find, in my opinion. And believe that that's just a fact. And here's a little example of it, especially question 2. Doing it a standard roundabout way would just be much more complicated instead of just using some good integration to find it. And some applications of it is area between the curves, or well, area in between curves, distance, velocity, acceleration, volume, average value of a function, work, center of mass, kinetic energy, probability, arc length, and surface area. And a lot of those are physics. So the integrals are very important to know and understand. And here's a little example as well of how they're keeping track of the flow of the water going into the bucket over the time, as well as keeping track of the volume inflowing into the bucket over time as well. And they're trying to find the area of the volume and how fast it's filling up over time, which I thought that was pretty neat. And then here's some real world applications of it, like jobs, like an astronaut, any type of engineer, you will use it for pretty much all of them. A mathematician, of course, software developer, post secondary teacher, an economic, or economist. That one was pretty interesting, but I can definitely see why you would need to use that for charts and stuff like that. And operations research analysis. And here's a little photo of electrical engineering where you'll use you use integration to find an area of curve. I believe this is for current. You're trying to find the current. I do believe, but I haven't gotten this far into like my math career to get to my engineering courses, but I do believe that is what is happening right now. So, but I thought that was pretty neat to show in here. And there's my citations. So, hope you enjoyed it.